Okay, so we mentioned last week that some of the parts we were going to have to make for this big competition rocket are going to be custom made, and we're going to 3D print them. But the way that we need to design those parts to be custom made is something that you guys might not be familiar with. So today we're going to be doing a tutorial on CAD design. So you'll go to Canvas, you go to modules over here, and then you should have an assignment right here called CAD tutorial. Okay, so CAD stands for computer aided design. And what we're going to be using is a website called Tinkercad. So if you just type in Tinkercad into Google, it'll take you here to this website. For you guys, you're going to need to click join now unless you've already made an account previously. And I don't have a class set up for y'all through the district or anything. So you're just going to do create a personal account. Okay, you can sign in with Google or however you want to do it. I already have an account, so this is what it'll look like once you get signed in. Tinkercad has their own tutorial system that kind of walks you through some of the basics with camera control and that kind of stuff. You're more than welcome to go through that if you want. But once you get done with that, we're going to go through and do kind of our own tutorial where we walk through how to actually design a part with specific dimensions that we need. So if you want to do those Tinkercad tutorials that it shows you when you first log in, go ahead and do those, and you can come back to this video and I'll walk you through your next steps. So the first thing you're going to do when you want to make a new part is you're going to come right here to create a new design. Okay, and this is kind of the blank workspace that it's going to show you. Okay, the way Tinkercad works is that unlike a lot of other CAD software where you draw a 2D sketch and then extrude it out into 3D, with Tinkercad you basically have a set of shapes to pick from, and you combine those shapes in whatever orientation or size you need to make your desired part. So what you guys have today for your assignment is, if you go back to your tutorial assignment and click on this link right here, it'll take you to an engineering drawing that I made for this sample part. Okay, this part isn't really anything like important or special. It's not an actual part that we're going to use. It's just something to show you guys the basics of Tinkercad and get you used to designing pieces to specific dimensions. Okay, all of the dimensions on this page are in millimeters. So if this says 45 from the center of one hole to the center of the other, that means there's 45 millimeters between them. Okay, and what it's showing you on this drawing is 3 different views. You've got the view from the top, you've got the view from the front, and then you've got kind of a like diagonal view where you can kind of see it in 3D. So basically all this part is that you're going to be designing for this tutorial is a oval shaped just flat piece that we've extruded up with 2 holes in it. Okay, so that's what we're working on. So the first thing that we can look at here and see right away is these dimensions for the sides and the height of this piece. So if we look at this, the dimension across the top, so from here to here, is 30, and the dimension from the top to bottom is 30. Okay, so basically what that means is that the central part of this piece here is a 30 by 30 square that's been extruded out into a long rectangular prism. Okay, we don't know how long it is yet, we can figure that out eventually, but in our design here, that's what we can start with. So you're going to grab this square, or this box, or cube, or whatever you want to call it. You're going to click on it, and you're going to drag it into your work plane, and then click to plop it down. Okay, once you do that, you're going to be able to change the dimensions of it to whatever size you want. Okay, you can do that either here, through these sliders, or by typing in these little boxes here. But the way that I like to do it is by clicking on these little nodes on the part itself. Okay, and those let you control it directly here without having to worry about the sliders or anything. So what we know, based off of our drawing, is that this dimension, the height of our box, should be 30 millimeters. And so we can click here and change this to 30. And we know that the dimension from the front to the back, or across, should be 30 millimeters as well. So we can click right here and change this one to 30. Okay, so what that gives us is a 30 by 30 square on this side here. And then all we've got to do to change the length of it is change this value here. Or you can click and drag. But the issue with that is that you end up not being able to drag it in a straight line. So then you get to fiddle with trying to get it exactly back how you want it, right? So one useful thing, if you do make a mistake like that, Control Z is the undo button. So that'll take it right back to where you were before. Okay, so the next step that we're going to look at here is trying to figure out, based on these dimensions that we're given, what the length of this middle piece here is. Okay, what we know for sure is that the length of our whole part is 90 millimeters. Okay, so if we came in here and said that this was 90 millimeters long, that should be the size of our entire part. The problem with that is it's not just a 90 millimeter rectangle. Okay, on the end, on either side, we've got these little semicircles, these arcs. Okay, and those, if we look right here at this value that we're given, the R15, what that means is that this arc has a radius of 15 millimeters. So we can use that to figure out the distance from where the rectangle ends to this point right here. This distance of this line that is shown here is 15 millimeters. And then the same thing on the other side. We have that same exact arc of 15 millimeters as well. So total of this semicircle and this semicircle should be 30, which means the middle section would be 90 minus that 30 for a total of 60 millimeters. Okay, so based off these dimensions that we've been given, of our piece being 30 milliliters tall, 30 milliliters wide, and then the central part being 60 millimeters long, we've got our first little bit here completed. Okay, before we go any further, I realized I didn't really explain this. One really important thing when you're working in 3D with CAD is being able to control the camera. And different software has different controls for the camera. So what you guys can use that will probably be the most intuitive for y'all is up here in the top left, there's this little cube. If you click on any of the faces of this cube, okay, it's going to rotate to show you that face of your square. You can also just click the cube and drag to rotate it like that and change how you're looking at it however you want. Okay, I have mine set up to where right click does that same thing, so I can rotate this around easily and look at it from any different angle I want to. I'm not sure what it's set up to by default on your accounts, so that's something you might have to play around with and get used to. And then to zoom in and out, you can use the scroll wheel. Or you can come over here and do plus and minus as well. So that's controlling the camera. That's going to come in handy to show you guys different angles while you're working. But our next step here to our piece is going to be adding these semicircles on the outside. Okay, and luckily we have a semicircle tool that we can use. The problem is if we click that and drag it in like the other one, it comes in flat on the ground. And that doesn't really do us a whole lot of good, right? So what we need to do is find a way to put that semicircle on the end of our piece here. And you can do it by taking this semicircle and rotating it using these controls here. Rotate it up like that, and then, you know, drag it over here until it meets up with the end and try and get it to match up exactly. And that's, I mean, it'll work eventually, but the easier way to do that, let me delete this real quick, is to use the work plane tool over here on the right. Okay, this tool up here in the top right, if you click it and then click on one of the faces of your shape that you're making, it creates a new work plane, and now anything that we drag in is going to be on that plane. So you can see, if we put this here, it's automatically lined up exactly flat piece to flat piece with our other shape. Okay, so once we drag that in, obviously we've got to make it the correct size. So we know the dimensions of this that we already set up were 30 by 30. So we can make this the exact same, 30 by 30. And then if we go back and look at our drawing here that we're basing all this off of, the radius of this arc, or of this semicircle, is 15 millimeters. So we've got to take this value here and set it to 15. Okay, so we've got the correct shape showing here now. But now our issue is that it's not lined up. And again, we could sit here and fiddle with it and try and get it to line up exactly right. And with these ones, because they're nice square shapes, it's honestly pretty easy to do that. But when we start working with circles and trying to get your nose cone aligned directly with the cone aligned with the regular cylinder and all that to get them to line up, it can be pretty tricky, especially when we're talking about differences of like 1 millimeter or half a millimeter. So the way I want you guys to do this is we're going to use what's called the aligning tool to do this. So to do that, we need to select both of these pieces, which means we need to come over here and click on our red piece of the center, and then hold Shift and click on our semicircle. And then up here in the top right, there's this little guy here called the Align tool. If we click that, it brings up this new kind of display, and these little dots will let you align things in any one of these different dimensions. So if I click this dot here, it's going to align everything along this top line, and then if I click this one here, it's going to align everything to the right. So basically it took the top right corner of our semicircle and moved it exactly to the top right corner of our rectangle, and it gets them lined up perfectly. Okay, once we have that down, you can click that again to exit the tool, and we can repeat the whole process on the other side. So we're going to come here, grab our work plane, put it in like that, get a semicircle, put it on there, and then change our dimensions to be all the correct sizes. So we want it 30 by 30 at the base with a radius of 15, just like the other one. And then again, we've got to get it lined up. So we can click on our red one, hold Shift and click on the gray one, or another way to do the same thing is to just click and drag and select everything all at once like that. Either way works, they both do the same thing. Once you've got them all selected, you'll click your Align tool again. Oops, my bad. Click your Align tool, and then we're going to line everything up with, let's go with this bottom left corner over here. Okay, so we click the two dots to get everything to line up, and now what we've got is a shape here that looks just like this one, just without those holes cut out of it, right? If we look top down at both of these, they've both got the long rectangular section in the middle with the two semicircles on either end. Okay, so the last thing we're going to do here is we're going to come in, select all of these pieces, and we're going to use what's called the Group tool to stick them all together permanently. And we can undo it, of course, later if we need to. But what this does is it prevents you from making a mistake where you try and grab one piece to move the whole thing and it comes apart, or you change the size or whatever, right? So that can be really annoying when that happens. Obviously you can Control Z to undo it and put it back, But if you're just trying to move the whole thing, you don't want to have to select it all and move it together. I don't know what's going on there. Okay, so to prevent that, what we can do is select everything and use this tool here, which is called the group tool. If we click on that, it smushes all of these, it smushes all of these together into one big piece. So now if we click it, the whole thing moves all at once. Okay, I'm also going to put our work plane back down at the bottom. Hang on, I don't know what's going on with the... Okay, I'm going to put our work plane down at the bottom. I'm going to group these back together. Okay, and what we should have now is something that is 30 millimeters across by 30 millimeters tall by 90 millimeters long. And that matches what we've got here, 30 by 30 by 90. Okay, so the last step we've got to do here is to put these holes in. So what we're going to want to do, they've got two different types of cylinders here. You can use the one that's already a hole, or you can use a regular cylinder and then make it a hole later. Either way, it works. Personally, I prefer to use the regular cylinder because it just, I think, stands out better and lets me see it. Also, one of the tricks I like to use is if I'm trying to position a hole in a piece, I make my original cylinder way taller than it needs to be because it lets you grab it easier and move it around, rather than if this was exactly the right height and I moved it, oh, that's not what I wanted to do, and I moved it inside this piece here, now it becomes a little bit more difficult to grab that piece by itself and move it around, right? So I like to leave it tall. You can move it around just by clicking on it and dragging it. And I think that makes it a little bit easier. Okay, but when we go back and look at our piece here, the first thing we're going to look at is the size of these holes that we're putting through it. And what this symbol right here means is that they have a diameter of 15 millimeters. So we can come here to our cylinder and change the dimensions on it to be 15 by 15, and that will give us a cylinder with a diameter of 15 millimeters. Okay, so this is what our hole should look like. And what we're going to do is we're going to use the copy and paste tool to make a duplicate of it. Control C and then Control V. Okay, and what we need to look at here is the distance between our two holes here in our drawing. This says from the center of one hole to the center of the other should be 45 millimeters apart. The easiest way to do this in Tinkercad is to use the ruler tool. So if you come up here to the right, you can click this right here, which is the ruler tool, and then click any spot on your work plane, and it'll put down an origin point that we can base the rest of our dimensions off of. Okay, these yellow or green or whatever color lines these dimensions are here is the distance from the bottom left corner of this circle to this origin point. So if we set these to 0, 0, then this bottom left corner of our cylinder would be right here at this origin point. Okay, but what we want in order to measure a distance of 45 millimeters from center to center, like it shows on this drawing here, is for our center of our cylinder to be at the origin point. So in order to make that happen, if the diameter is 15, half of that would be 7.5. So we can set both of these values here to negative 7.5, and that will put the center of our cylinder right on that origin point right there. Okay. The next thing we want to do is arrange this one so it's exactly 45 centimeters away from the other one. So we can put the y value at negative 7.5 as well, so that its center is right on that bottom axis. And then this distance here, remember this is measuring to this bottom left corner, so it needs to be 45 millimeters plus 7.5. That's not right. It needs to be 45 millimeters minus 7.5. So what we would say right here is we would say I don't know the math off the top of my head. That's what calculators were made for. We can say 45 minus 7.5 gives us 37.5 millimeters. Okay, and what that should do is now the center of this is 45 millimeters away from the center of our other one. This is the trickiest part, honestly, is dealing with these circumferences. Tinkercad isn't really set up for stuff like this. It's a lot easier in a real CAD software like Fusion or Onshape or SolidWorks or anything like that. But, you know, we do the best we can with what we've got. So this is one way that we can kind of jury rig it and make it work. Once these two are separated the correct amount, and we've got 45 millimeters between the center of one circle to the center of the other one, what we're going to do is group them both together. So hold shift and click on both of them, and then group them together. And now if you click one and drag it, they both move with it. Okay, and we can use that to group them, or to align them, sorry, with our original piece over here. So we're going to select our piece of the two towers and our piece of this right here by holding shift and clicking them both. And then we're going to go back and use the align tool again. Okay, if we click this one that's right in the middle here, what it's going to do is align the center line of this piece with the center of our circles, which is good. And then if we click this one that's right in the middle here, it's going to align the center right between these two pieces with the center of our piece here, which is what we want for this to be evenly spaced. Okay, so once we've used the align tool and they're all lined up correctly, we're going to come in here, click on our cylinders, and instead of making them solid, we're going to turn them into holes. Now, this doesn't actually change anything. In order for them to actually cut a hole through this other piece, what we've got to do is select everything all together, and then the last step is to click the group tool again. What that's going to do is group it all up, and it makes those holes that we made cut right through this other piece. So we can look at it from the bottom and see they go straight through, or from the top and see the same thing. Okay, so that should be it, right? If we go back and look, we've got two holes. They're 45 centimeters apart. They each have a diameter of 15. We've got the two semicircles on the outside that have a 15 millimeter radius. And then our whole part is 30 by 30 by 90. Okay, which we can check all that here and it all looks correct. Okay, your last step, you're going to export this file as an STL. So you're going to click right here, download in 3D print. You're going to click .stl, and it's going to download it for you like it did down here. This is going to be part of what you submit for this assignment on Canvas. So you do start assignment, upload a file, and then I could go to downloads here and upload that I just downloaded. It gives them funky names. I don't know where those names come from, but and then the second part that you're going to have to do is go to the text entry. Click this one up here that says invite people to share this design with you, and generate a link, copy it, and paste that into your text entry. Okay, you've got to do both. I need the file of the STL, so I know you know how to do that, because that's how I'm going to get the files from you guys to 3D print your rocket parts eventually. And I need the text entry of the link to the actual Tinkercad model, so that I can go in there and check your dimensions on it and make sure you've got it right. Okay, once you've got both of those, you can click submit, and you'll be all good.